Hello everyone, I'm Aidan Boran. I'm actually going to talk about 4 projects, fairly recent projects that I've been involved in that used Node.js. A lot of the projects and developments that we've done are in the IOT space, Internet of Things space, so use constrained devices and so on. So I'm really focused though on one. It's an assisted living technology that we're currently working on. So, and I'll spend a little bit more time on that. I've got nearly 200 slides. No, I've got about 10 slides, so I won't keep you from your beer. So I'm Aidan Boran. I started a company called Next Big Thing about 9 months ago, and we're looking at developing leading edge solutions for assisted living, and I'll go through where that intersects with Node by explaining some of the stuff that we've done in the past. So Internet of Things, at least part of it, the bit that doesn't involve the internet is about embedded devices, so small devices that are going to connect themselves somehow to the internet. There's a really wide, this is absolutely not exhaustive, it's really my view and experience on different devices, but really wide spectrum of devices that you can potentially run software that allow you to connect to the internet. So if you look at the types of devices, you've got low end, these are really best for low power, so running in a situation where it's battery operated and you want to run for months or years even, and typically they're very, very low compute capability. So you're definitely not going to run Node.js on some of these devices. I'll talk about maybe why that wouldn't be such a good idea anyway in subsequent slides. As you look across from mid to high, there are a lot of the big players, let's call them. Everyone's familiar with Arduino and Raspberry Pi, and they provide a lot of really useful devices for prototyping things. When you go to high end and you want to do any sort of machine learning or processing of images very, very close to where the device or the camera is, then you need quite a bit of compute power for that. And luckily over the last 4 or 5 years, a lot of the processors that drive your mobile phones, these are made by Qualcomm and companies like that. So you can buy development boards, think of these as Raspberry Pis on steroids. They're 4, 8 or 10 core. Some of them have multiple GPUs. There's ones coming out with FPGAs on them as well, which will really boost up the capability. So I'll pass around a few so you can actually see the form factor, which are very, very nice as well. Should have taken these out earlier. But I'll pass around that one there, which is one of my favorites. So that's an 8-core machine with 2 gig of RAM, 16 gig of flash with 2 GPUs on it. So it's capable of running, not alone Node.js, it's capable of running a lot of the deep learning. So Torch and TensorFlow, if people are familiar with that. So I'll go through what we've done in Next Big Thing in terms of running some kind of cool vision analytics, basically. So I'll pass them around, and that one, by the way, is dead, so you're quite happy to. So just to, before I move on, so there's still value on this side for lots of sensing and Internet of Things, where you want to do sensing of maybe temperature, humidity, a lot of environmental conditions that we want to sense. If you really break it down, temperature and humidity is it's a byte, it's an int or a float or whatever. So you don't really need exotic hardware to actually transport that from one place to the other. What you might need is actually a good wireless connection. And the Internet of Things has been good in that respect, in that it's brought in some very low power wireless technologies. And again, the favorite one that I like using, which I will pass around as well, is called LoRa, or L-O-R-A. So LoRa is essentially a very long range, low power. So long range means even without an antenna, with a piece of wire as an antenna, it's about 2 kilometers. You put a proper antenna, a tuned antenna, you will get about 20 kilometers. And there are other competing ones, another one called Sigfox. Why don't I just peel these guys out here? So I'm going to pass around a small sensor node. This one does work, and it's one of about 4, I think, in the country, so I would like to get it back. So this one is actually multiple wireless radios on it. So it says Wi-Fi and Bluetooth. It actually does Sigfox and LoRa as well. So it can switch on and off different radios on this particular, so pass that along. And that one is running a 32-bit processor with about 4 meg of flash, so more than enough horsepower on that one to do some interesting things, which maybe we'll show later. So you go across here, Intel Edison is a nice Linux-based platform that will let you run Node.js and do all sorts of interesting things with the GPIOs. The Arduino Ion is basically a Linux computer on one side and an Arduino on the other, and there's a little bridge between the two of them, so you can read sensors using your old or existing Arduino code and then shunt it off to all sorts of interesting web services. When you get up here, these are really the high performance nodes capable of running lots of interesting things. Before I started Next Big Thing, I worked for probably the last 20 years in the telecoms industry, and this little high keyboard that I'm passing around, we did a benchmark on it once, and it had a far superior compute statistic from the benchmark than the desktops that the company were giving people to actually work on. So it's cheaper as well. So just in terms of the environments then, so whether it's low, mid, medium or high, I really just want to emphasize that even on the high, we have a lot of compute power, but memory is still quite, both in terms of RAM and in terms of flash, is quite constrained as well. When you're over on this side, on the low end, so you're talking the ubiquitous Arduino Uno, for example, it only has 1,024 bytes, not megs or gigs, bytes in its heap. So you can't really do, it's actually worse than that because it doesn't have a memory manager. So if you allocate 200 bytes in the middle, you've kind of screwed up the top and the bottom. The mid devices like the Intel Edison, there are lots of different firmwares you can install on them now, which do a really, really good job at making the programming of the GPIOs. That's the pins and ports on it that let you read sensors and do interesting things with sensors. This company here called Mongoose, they're actually based in Dublin. So this is a JavaScript node-alike infrastructure that will sit on some of the devices I've mentioned. Lua, don't know if anyone's been using Lua. Lua, a lot of stuff coming out of both Facebook and Google now is based on Lua. So a lot of the Torch, which is this deep learning tool, which lets you do really cool things with image and vision processing, as well as audio processing, is based on Lua. So that needs to fit on somewhere as well. Once you go to the high end, it's really trivial to put Node.js on them. It's a Linux box, and sudo apt-get install will put the thing on for you in the vast majority of cases. As you go in this direction, we have been stripping out features. This will sound a little bit odd, but taking features out of the core Node.js stack, purely just to reduce the size of it so we can fit it on some of the smaller things. But I think as someone was mentioning earlier, one of the nice things to be able to do, I come from an old world Unix background, and everything was a Unix socket. And web sockets remind me of Unix sockets with just the word web in front of it. They're really handy to use. So that's really the only thing we try and port over. So let's have a look at what the key libraries. So if you want to take advantage of some of the lower level hardware, again, this is just my view of the so these are all Node.js libraries that you can pretty much grab and install. So let me just, so a GPIO is a general purpose input, output. So lots of different sensors can be connected to it, whether they're dumb analog ones or exotic or more exotic digital ones. And there's a number of standards that pretty much all of the sensors adhere to. And to be honest, with this collection of stuff here, I don't think there's a sensor on the planet that you couldn't actually connect to. I think one of the interesting ones here for any Apple fanboys is Homebridge. So Homebridge is really a gateway, a Node.js plugin which allows you to talk to Apple HomeKit devices that are so a device that wouldn't normally be accessible through kind of Raspberry Pi and that sort of infrastructure. The last one I put down in biggest is probably one of the most useful is Serial Port. It's an old one, but it's an oldie but a goodie because connecting. So this is really allowing you to do data comms. It allows you to debug. It allows you to potentially to flash software on and off the things as well. So that's quite a handy one as well. So Serial Port would be one way, really quick and dirty, very quick, very dirty way of connecting an Arduino to a Raspberry Pi, for example, without having to knock yourself out. So some other libraries that we found useful. So often we'll want to do, if there's any cloud people here, I hate cloud. I would keep everything local. Our company for assisted living keeps everything local. So we do need local storage and we need fast local storage. So the devices, AnyDB is like a lightweight MongoDB and NoSQL database, really good for fast inserts at the expense, obviously, of consistency. Neo4j is a graph database, so perhaps depending on your application, if you need to do kind of traversals of long chains of things, Neo4j is a really good one. So in the sensor space or IoT space, if you think of the ability to ask the database very efficiently for give me the last reading for every sensor that you know, and maybe there's 100,000 sensors, that's something that a graph database will be able to do, assuming you've structured it correctly. Co-op is a transmission standard, which a lot of EU companies are using, mainly because it was funded by structural funds from the EU. If you ask me, I wouldn't touch it. I would continue with doing your own thing with WebSockets, or if you must have, use MQTT and socket.io. Where would we be? Stone Age, probably. So just looking then at application development. So again, if we're building perhaps a dashboard or a configuration app that's connected to these things, we'll 99% of the time use Express. Node-RED is actually quite a useful tool for doing visual programming on these devices as well. Electron is one Node.js environment which lets you essentially take a web app and stick it onto a desktop, so we turn a web app into a kind of captive desktop app. So one of our applications is a kind of a captive kiosk. So this lets it run as, essentially take over the screen and power all that. Doing simple dashboarding on something like, this is a slightly less powerful version than the one I sent out. But dashboarding, the Mosaic tool again is Node.js. If anyone's familiar with some of the other dashboarding tools, there are Python ones out there and there are Ruby ones out there. They're a bit of a pain in the neck to use, but this one is nice and easy, and it has a D3 capability. D3 is this visualization tool for doing kind of funky visualizations. If I have to go to the cloud and I don't like it, I'll always use Heroku, and that's purely for simplicity. And the other thing is that most of the time it's free. Grafana is a way of doing dashboards and visualizing metrics. It's cloud-based, but there's also an open source version of it that will actually run on this guy as well. So really fairly straightforward to set up, with lots of different database backends that you can plug it into, and it lets you do really nice kind of statistical analysis without actually knowing the first thing about statistics, which is always a good thing. So this is the last of the pronouncements and libraries. So I mentioned that we do some deep learning on some of the data we collect. And the data comes from cameras. And while you were having your lunch, I was actually recording what was going on in the room and doing some analytics in the background. So we'll have a look at that later on. So, but again, there are a bunch of Node, and again, this is absolutely not exhaustive. In fact, if you go into the repository and just do webcam or camera, there's hundreds of them and they're all pretty good. A tool that you won't, that maybe you will have heard of, or if you haven't, it doesn't matter. It's called FFmpeg. If you want to do anything with video, FFmpeg is your man. It'll run on everything. It'll do conversions. It'll read cameras. It'll read, even on the Mac, which is usually fairly nasty to get stuff working. It'll automatically pick up the cameras. For vision, OpenCV again. OpenCV, Open Computer Vision. A really great tool. It is an absolute pain in the ass to install on anything, but once you get past the install, it really is cool. I'll show you some of the, in video, show you some of the capabilities of that. So that lets you do any algorithm in computer vision research over the last 20 years. There's an implementation of it in OpenCV. Now you can do some really interesting stuff. In due course, OpenCV will get taken over by the new kid in the block, which is this deep learning thing, particularly for image and for vision processing. And we're doing some of that in the assisted living space. So think of an elderly person living at home, and we have a camera that's taking pictures periodically, and we're doing scene recognition. So what that means basically is it's perhaps counting the number of people in the room, it's doing gender analysis, it's deciding whether you're in the kitchen and figuring out how, whether people are sitting or standing or walking and how active they are. So I'll talk a little bit about that. I put a warning or alert, a yellow alert here. The Node driver for OpenCV only supports quite an old version of OpenCV. So until such time as they update this guy, just be cognizant of that if you are using it. So I'll very quickly fly through two projects to get to the assisted living one that I really want to talk about. So this is, so the purpose of these two examples just to show what usage Node.js is. So, and it's really the same for both, that Node.js we've run on the gateway node. So think sensors are dotted around your home or your enterprise, and there's a gateway listening for the wireless communication coming off. And it's usually here that we run Node.js in order to do orchestration and essentially have a stack running here that's listening and sending stuff to potentially to the cloud if you want to do that. So libraries that we've done is a lot of bridging between incoming wireless messages. So you will have different radios connected to this guy. Some of them are serial, some of them are I2C, and some of them are SPID standards. We also use Socket IO, MQTT, Co-op, and NEDB. So with that mix, we've pretty much been able to do everything. I'll jump to the next one, because this is a little bit more interesting in terms of wearables. So this is a project that used our old friend here, the gateway node. So this is essentially technology to allow you to understand spatial relationships. So at the Web Summit in 2000, I think it was 2015, we deployed for a lot of the delegates, I'll pass this around, we deployed a little tag. So what's on the people's badges is actually a wireless transmitter and a battery, and it's using low-level IOT 2.11 management chatter. So periodically these, if I come close together and you're wearing a badge, the gateway is actually listening for the RF interactions, the fingerprint of the RF, and we're able to figure out that how long that we've spent together. So Web Summit, Glitterati were interested in understanding when investors were talking to startups, how long, what the group size was, and stuff like that. So this was a technology that we used Node.js here to essentially implement a Node.js wrapper to do sniffing over WPA supplement and the IEEE 802.11. So if anyone's familiar with that, down in the bowels of 802.11 there's a management message called a probe, which is a wireless device will use to figure out if an access point is in this region. So these little tags we have send out lots of different probes, special probes that we're listening for that interfere with other badges, so that's how that is done. So again, I really wanted to talk about this, and I have 2 or 3 slides and then a quick video of what you guys did at lunchtime. So assisted living, again, this is my definition. We're really looking to keep elderly people at home for longer, keep them safe in their homes. And why would you do that? Well, the benefits for the individual in terms of their mental health and physical health, the local community benefits, you get to keep people in the community for much longer, and society in general. So how does society benefit? Well, in 2013, the HSE made about 60,000, had 60,000 people access home care service packages, cost about €500 million. If you look at the growth statistics for the population in Ireland, we're all getting older, and unfortunately we're all living longer, or fortunately. And if you project out to 2030, about 30% of Ireland's GDP would need to be spent. If we followed the current route, 30% of Ireland's GDP would be blown on just those home care services. That's totally untenable situation. Lots and lots of technology out there already. So why isn't it helping? Well, there's major usability and efficacy issues with it. Some of the smart home technology can help. However, there are a demographic that I'm calling the worried well. So these are people like me who buy Fitbits and smartwatches, and get a cold passing a hospital when they're really fine. These are people who are interested in making sure that both themselves and want a technology solution to help understand maybe what their elderly parents are doing. So if you take some of the technology that we're all working on and try and apply that in the home for this particular use case, then I think we can do something that's actually much, much better. Frankly, a lot of the solutions out there already are really recycled home security systems that are constantly alerting you to false positives. That's not what we want. And there are four or five key triggers for elderly people that are important to look at. One is their sleep cycle. So you can predict ahead of time a change in both mental and physical state from how people are sleeping. And it's the same with their gait, how people walk, whether they're how they're carrying themselves, general mobility and general facial expression. So all of those things are potentially mineable just by having a camera or cameras in the area. So that's really what we've looked at in Next Big Thing to try and figure out what we could do in this area. So how it works basically is that we add a number of pre-configured sensors on the gateway. So these are all precast at factory time. And what happens basically is we have a number of optical sensors. So this is a little battery operated camera. And this is a remote head for, I'll need this one back as well. So what this is doing is taking images wherever you want to put it, sending it to our friend here, and our friend here is doing the deep learning, running some deep learning vision algorithms to figure out what's going on. So what can we do right now? So right now, one of the things we want to be able to do is when you put it into the house, particularly if it's elderly people, you don't want complex setup. You don't want to be setting dip switches. You want the thing to work and to transmit through old houses and new houses. So some of the standards like LoRa and Sigfox are really, really good at indoor penetration, going through walls and so on, multiple walls. So we install our system, a number of these nodes, they pair up with the gateway, and the AI in the gateway then builds this hypothesis. So think of this as your Nest thermostat learning what you're doing. So what it's doing is it figures out how many unique people are in the house. It will do gender recognition, so it'll say there's 2 men and 2 women. It'll take an initial baseline then for gait and sleep, and the initial baseline for mobility and occupancy, so that's what rooms do you spend your time in, and so on and so forth. So once it's built that hypothesis, it'll ask the relative of the carer to actually validate. So that's kind of the end of training or learning, and you can say, no, I don't agree with that, there's only 2 people, and you said 3, and you can exit out. If you do accept, that's really a baseline from which we look for change in the future. So the software will just do the same thing over again, every day, and if it sees a difference, then it's time to actually alert and take some action. So predictive and easy to use, yeah, right. Sorry, animation, totally forgot about it. So let's just look at some of the raw images. So I think it's important to say privacy and security, particularly for elderly people in your home. So you're hitting a lot of red flags there in terms of privacy. So that's one of the reasons I hate the cloud. So try and keep everything in the house. Sorry for any cloud people here, I'm really only messing. So, and although we take lots of pictures, all of the pictures and video that we take are actually discarded, and it's really the inference from that video that's actually stored. So for example, if I click this one here for sleep and gait, one of the underlying algorithms you might use is called optical flow. Whoops, wrong one, it's gone. So the top one is optical flow. So that's actually computing movement vectors, so speed of movement and direction of movement. If I subtract the background from the image, then as I sit back in my chair, you can actually see me blink in the background, and count blinks and so on. The bottom one is a thermal camera. So again, thermal cameras 5 years ago, you'd need a second mortgage or a third mortgage or whatever to buy a thermal camera. Now, FLIR released a thermal image sensor for about €200. So the problem with it is, as you can see here, it's 80 by 60. However, it's still 80 by 60 pixels. It's still good enough to do sleep analysis. So think of this sitting in a bedroom, and you can divide sleep into either 5 or 6 categories depending on the research you read. So we can classify people's sleep from the thermal images. And it's got some advantages in that a lot of people use apps. They'll put the phone under their pillow. If you're like me, you'll forget to switch it on or the battery will run out. Other ones use pressure sensors on the bed. However, pressure sensors, particularly the ones that use piezo, suffer drift when the temperature changes. So if your elderly person puts on an electric blanket, a favourite object in Ireland, or somehow the bed gets wet, the drift of these sensors is really invalidates it. Aside altogether from the somewhat medieval look of the way some of the tech is actually instrumented at the moment. So we think we can do some interesting things there. So just bringing it back to Node.js. So where does Node.js fit in all this? Well, so again, Node.js is sitting on our gateway node, and it's providing the overall orchestration, transport of images. It's supporting the image processing pipeline. So underlying a pipeline is, I grab the image, I do a face detection, I see if this person is smiling, or I do motion vectors on it. So all of that goes on via Node.js. And Torch and TensorFlow are the two tools. Thank you, Google, and thank you, Facebook, for creating these tools. They're Lua based, so what we've done is taken a subset of it and created a Node.js, because that was our kind of favorite tool to use. So all of this is going on the gateway node, and nothing leaves the house in terms of the data. So it's really the opposite. Think of it almost as a reverse cloud, that we have an app on your phone which you can tunnel in using a secure connection. You can tunnel in to this node and see a dashboard using, guess what, one of the other libraries that we spoke about earlier. So just looking at some of the things you can actually do. I'll show you this one. So this is what I used earlier. So taking repeated images and comparing pixel by pixel to where things have changed, and overlaying a heat map. So this one here is doing face in the motion. I'm disgusted and sort of sad. So this highlights both the power and the issue that training the machine learning algorithms takes a lot of effort as well. So that's one thing that kind of distinguishes us, that we have partnered with companies called Third Age, which runs care services in Ireland. So they've been very helpful in providing training data for us to actually tune the algorithms. Here's a really interesting one. So what this is doing mad magnification on my head, and when you change some of the color filters, you can actually see blood flow across my forehead, and you can watch the pulse and essentially do a pulse detection. So this may sound like science fiction. It's actually one of the tutorial sessions in OpenCV, so you can take credit for that. So last slide, this is the quiz. So what have a Wavin pipe, a relay, car battery and a coil, can of hairspray, not my hairspray by the way, a potato and Node.js got in common? This bad boy here. This is a Wi-Fi potato gun. So you put potato in here. Hairspray is a fantastic accelerant, so squirt of hairspray in here. Battery and ignition coil. Where Node.js comes in is an Arduino Young. So I have an app on my phone with my kids that we can fire a very loud and somewhat dangerous potato at the neighbours when we walk in. It's the picture.
Any questions?
Hi, I just want to ask you about what's your objection so much to the cloud because of in machine learning. Like I use machine learning a lot, that's my project was, and I know that the cloud is so good. Here. It's so good for that. You can get it's so big, you have access to massive computation power. And I know you have like a couple of GPUs on the small things, but again, it's still, there's limitations to it.
So, no, absolutely, and I was being, this is the image that we took when we were having lunch, so it'll color code who was the most active in your course. But GPUs, no, you're absolutely right, particularly when you're training data, it's impossible to train on those little nodes. For the assisted living solution, we wanted to keep everything in the home or in the care center. For security and privacy reasons, that's really the only reason. The other issue, the reason we went with local processing is that as the stability of internet connection in Ireland, particularly in rural areas where some of these devices are going to be sitting in the home, it's not, if the prerequisite is that you need broadband and you need to connect to, Microsoft's Oxford or something to do, your recognition. So there was really not a technical machine learning reason to do what we did. It was really more to do with what we foresaw or foresee as the environment we're going to put the box into.
Hey there.
That's freaking people out. Sorry, go ahead.
Yeah, really good thought, thanks. Just wondering about, is it like a general algorithm that you then tailor to the individual, or that you, or is it just built up from the beginning for each individual?
So the data, for a lot of the machine vision things, the data is trained on hundreds of thousands of images of all shapes and sizes. And that's what makes it generalizable over a general population. So the more training you do on it, it's probably the dirty little secret of machine learning, that the effort that goes in, and that's where the cloud comes in. We do our training. We still don't do our training in the cloud, not because we don't think it's a good idea. We do it actually on a Mac Pro, which is a 32 quad thingamajig that costs a fortune, but it's the only, and it will still take maybe 2 or 3 weeks to complete the training phase on those images. So it's not a zero sum.
But is it personalized per client then after that?
In the sense of
gait or pulse or sleep cycles, I know that.
So the gateway that we put into the home is per client, so that data is secured and tagged as their data. But it will work, if you put it anywhere, it will work and be able to do that analysis.
Thank you.
Hi, how's it going? You mentioned a lot of these sensors are wireless. You mentioned some of the ranges like 20 kilometers or so. While you mentioned there that the app can, as you said, tunnel in and the security of the device there, have you ever given any thought to the data that's going between the sensors? For example, if someone was to use a software-defined radio, to listen to the signals going back and forth? Like, is there encryption between the different nodes, or have you even thought to that kind of security?
Yeah, no. So the LoRa, we use a standard called LoRa, which has the encryption built in. So it's a 256-bit encryption key on the data between the client and the server. So I think once we go outside the home, we're not planning to go outside the home with anything exotic other than the normal, SSL and so on, security certificates. So, it's definitely a concern or issue with a lot of the IoT tech that's out there. One of the things that we've done is actually buy a lot of the IoT tech, Samsung stuff, some Nokia WeThings stuff, and take it apart to actually see what's actually going on inside in terms of the chipsets as well. And whatever about software-defined radio and listening for the physical access to these devices is seriously problematic as well, because most of them leave JTAG ports wide open, so anyone with any little bit of a USB cable will be able to connect in. I think on the security side, I think ultimately, the telecoms companies will crush out LoRa and Sigfox and any of the other long-range ones in favour of something called